Learning Target 8.1 is all about the properties of exponents. Now you can use the definition of an exponent to kind of help you figure out what the properties are, but you need to show the work for the properties. So first of all, just multiplying two things together. I know that I need to multiply the 12 and the 8 together because it's multiplication between there. But now I need to figure out how to multiply x to the 8th times x to the 21st. Let's go for just a second and do two easy ones. X squared times x cubed. X squared would be an x times an x. X cubed would be 3x's multiplied together, which means by the time I multiply these together, I'd end up with 5x's. So when I multiply things with the same base, it means I have to add the exponents. So over here, I'm going to do x to the 8 plus 21 power, which is going to then be 96x to the 29th power by the time I'm done. Same thing here, negative 9 times 3, and then a to the 4 plus 1 power, because this is a to the first, and b to the 8 plus 15 power. That's going to give me negative 27, a to the 5th, b to the 13th. I do not move anything to the denominator because I have no negative exponents. Raising a power to a power. Think about what this really means. What it means is I would have a 4m to the 12th times another 4m to the 12th times yet another 4m to the 12th. So in that would be a 4 times a 4 times a 4, which is 4 to the 3rd power, not 4 times 3. And then I'd have 12 m's, 12 more m's, 12 more m's. I'd have 36 m's. So when I raise a power to a power, I multiply the exponents. So I end up with 64 m to the 36th power. Using that power to a power rule, this is x to the 6 times 14 power, so x to the 84th power when I'm done. Dividing things. Well, 36 divided by 9 is easy. 36 divided by 9 is 4. But think about what happens. If I expanded this out, I'd have 22 p's expanded out in the numerator and 14 p's in the denominator. 14 of those pairs would cancel out, leaving 8 p's in the numerator. How do I show that I get that 8? I show that I am subtracting 22 minus 14. So 4p to the 8th power is my final answer, and this work shows I know the property. Same thing, x to the 8 minus 20 power would be x to the negative 12th power. Here, however, though, you are not allowed to have a final answer with a negative exponent. Negative exponents, if you remember, talk about reciprocals, but really the way we kind of looked at it was, it's like the little thought bubble above a cartoon character's head. And it's thinking negative thoughts, so it wants to move so it can be happy. Well, it's in the numerator now. The thing that's going to be happy is for it to move to the denominator. Now its thoughts become positive, and then there really was a coefficient of 1 out here before. The 1 stays in the numerator. Anything to the 0 power, d to the 0 power is equal to 1. It's not equal to d to the first. It's just equal to 1. So d to the 0 becomes 1. 8 times 1 is just 8. So this really becomes just 8 squared, which is 64. And last but not least, the k has a positive exponent, so it wants to stay in the numerator. The j with the negative exponent is not happy where it is in the denominator. It wants to move to the numerator. Alphabetically, j comes before k, and then once that moves, its exponent becomes positive. The m has a negative exponent in the numerator, but once it moves to the denominator, its exponent will become positive. So this one didn't have a work step, any work that you needed to show. It was just moving things to make positive exponents.